All right, let's see. Martha, can you tell me how do you set up the next one?
X plus 3 over 2 equal to plus or minus radical 1 over, is it 4 or 9? 1 over 4, I believe.
Exactly. So if I subtract 3/2 from both sides of the equation, I get x equal to minus 3/2 plus and minus square root of 1/4 would be 1/2. So x would be equal to minus 3/2 plus 1/2, and x equal to minus 3/2 minus 1/2. So here we have minus 3 plus 1 would be minus 2 over 2. Now if these need to be added, if they have a different denominator, you have to use LCD, of course, right? So this would be minus 3, would be minus 3 minus 1 would be minus 4 over 2, which is equal to negative 2. Okay. Any questions so far?
How does 3/2 become a negative? Oh, did you move to the other side?
Yes, right at this point here, I want to isolate the x, right? So I subtracted 3/2 from both sides of the equation. Do you see that?
Yes.
Okay. And then, of course, you have to check your answer, make sure all these numbers work. So you put negative 1 here, add it to 3/2, square it if you get 1/4, and you do the same thing for negative 2. Add it to 3/2. You have to find the LCD and all, and see if these are all the real solutions. But in general, if it's a solve by square root property, that's what you do. If you have something square, once again, if you have something square, let's say we have x squared is equal to let's say 5. Okay. If I want to eliminate this 2, I have to raise both sides of the equation to the power of what? Amelia, how do I eliminate 2?
By using the square root?
Yeah. 2, in other words, 2 times what is equal to 1? 2 over 1 times what is equal to 1? What's the fraction?
1 over 2.
1 over 2, exactly. So we're raising both sides of the equation to the power of 1/2, right? So if you remember, if I have a to the power of 1/2, what is a to the power of 1/2 in terms of square root? How do I change it into square root? Anybody remember that? As a matter of fact, if I have a to the power of m over n, that means this is the same as square root of a to the power of m, and then nth root of that. So remember that. So this would be really a square root of a to the power of 1, and that would be square root of that. So a to the power of 1/2 is a square root of a. So when we are raising both sides of the equation to the power of 1/2 to eliminate this 2, really what we're doing is we're taking the square root of both sides. That's what we're doing. Because the square root is nothing but raising it to the power of 1/2. That's why this 2 and the square root would cause to have only x here, because the x 2 times 1/2 is the same as 1. We get x here. So on the other side, we get square root of 5. Again, we expect to get 2 solutions. That's what we have. Those both plus and minus will be the solution to this. Now we had this problem slightly worked out differently. If I have x squared is equal to 4, we used to move everything to one side of the equation by subtracting 4 from both sides of the equation and then factor it. That's how we used to solve this. And this is difference of square. This becomes x minus 2x plus 2. So we say x minus 2 is equal to 0, or x plus 2 is equal to 0. So there we have x equal to 2, or x is equal to negative 2. Do you remember how when we solved the problem this way? So now we are using
x equals
the different method. Yeah, now we're using this different method. We're using the square root method. So we're taking the square root of both sides and we're putting a plus and minus here. And we get the same answer, x equal to plus and minus 2, as we did here.